All right, so the math dealer here, and today we're going to learn how to solve systems of equations. And I'm going to look at the two methods, substitution method and elimination method. So the first one I'm looking at is what they call the substitution method. And basically what this is, it's when you have two equations and you have two unknowns, right? I have x's and y's in both of these. And your mission is basically you're solving for x and y. And we oftentimes write that as an ordered pair. But really, that's what we're doing. We're trying to solve for the x value and the y value, because if I were to graph these two equations, they would actually be linear and they would intersect somebody. So that's why that teacher of yours keeps on talking about lines and linear equations, because that's what these are. Okay, so let's get going with this. So you have y is equal to 3x minus 1. So when y is all by itself, you can take what it's equal to and just plug it on in. How fun is that? Very. So I have 2x times, right? And now I'm plugging in for my y. I'm plugging in 3x minus 1. Notice I am substituting. That's why we call it substitution. I am substituting whatever my y was directly in for the y. All right, but check it everything else, right? Everybody else stays the same. The 2, the x, the 5, the equals, the 7. All of those are still the same, okay? And all you're doing is replacing the y with 3x minus 1. Now, I'm sure many of you all are already kicking this thing out, right? Because you got the distributive property happening. So I have a 2x plus a 15x minus 5. Now, please, please, please note that 5 gets distributed to the 3x and the negative 1. That's why the 5 is a negative. I know, super exciting. So this is going to give me 17x when I combine like terms. 17x minus 5 equals 7. Now look, I'm writing all the steps down. And if anybody knows me as a teacher, I sometimes shimmy on through those steps. But not today. So 17x is equal to 12. And then I'm dividing both sides by 17, because your good job here is to get that x by itself. Because remember, you're solving for x. You're not solving for 17x, okay? So it gives you 12 over 17. I'll promise you, many students freak out when they get a fraction for an answer, but not you, right? Because guess what? Fractions are real numbers too. Okay, so now what I'm going to do is I'm going to take that 12 over 17 and substitute it back into one of my equations for the x. Now, I tend to go into the easier one, so I'm going to slide on into that y equals 3x minus 1. I plug in the 12 over 17. A little shimmy, shimmy, work. Please remember that 3 is like 3 over 1. So that's 36 over 17 minus 1. And no, you don't need to break out a calculator, because every one of you knows that 1 is really 17 over 17. So when I do that subtraction, yes, I get 19 over 17. So your answer, your final answer, alert the media. Final answer is an ordered pair. Because remember what I said, if I were to graph these two equations, they would intersect at the point 12/17 and 19/17. Yeah, it's sitting over there in quadrant 1, and it's like a little bit shy of 1 and then a little bit more of 1, but that's where it would intersect, okay? All right, so now that was the substitution method, and we use the substitution method, like I was saying, when you have one of the variables already by itself. The other method I want to look at is the elimination method, okay? The elimination method, that's the method that we use when we're trying to eliminate, I know, right? So clever, one of the variables. But in order to do that, the coefficients must be opposite. So either they have to be opposite in front of the x, or they have to be opposite in front of the y's, okay? And right now, they're not opposite under either one of them. So what are we going to do here? Well, we're going to make them opposite. So in that first equation, if I multiply it by a 7, that will get me a negative 14 sitting in front of that y. And if I multiply the second equation by 2, that'll get me a positive 14 y. And then I could cancel those y's. So watch. No, actually don't watch. Write this down. I know, right? Crazy thought. Take some notes. What are you, crazy? So anyway, so that's going to give me a 49x minus 14y, and that's equal to 105. Ooh, look at all that math. Now kick the 2 in, right? And what I sometimes do to make sure I know I've done something to the equation is I do that double arrow. I know it looks fancy, but you know what? Sometimes you just got to be fancy. Okay, so here we are, right? I distributed the 2 to all 3 of these terms, just like I distributed the 7 to all 3 of the terms. Now, when I add the 2 equations together, look what I get. I end up getting 53x equals, what's that, 159? Something like that. Well, now when I divide both sides by 53, I know you were starting to worry, but look what happens. X ends up being 3. Isn't that adorable? But you are not done yet. No siree. You have got to take that 3, plug it back into one of these equations, and solve for y. So since there's really no best one, I'll go ahead and plug it into the first one. And I'm going to just do a little work. So my 3 goes in for the x. Everybody else is just sitting around waiting for the party to get going. So 21 minus 2y is equal to 15. Subtracting 21 from both sides. Look at me looking at all these steps. I know my students are probably so impressed with me right now. I am writing down every one of my steps. Crazy, right? Now, when I divide by -2, lo and behold, yes, you see it. So y is also equal to 3. It just so happened they were both 3. Please don't think they're always going to be the same, as you learned in the earlier in the video. Okay, so there's my x, here's my y. The way we write our final answer, remember the final answer should always be written in your ordered pair. And in this case, you write your x and you write your y, but guess what? They were the same. So Merry Christmas. Here they are. All right. So I hope that was helpful. This is the Math Dealer signing out. Have a fabulous day.